So do you remember the definition of a parabola? Definition of a parabola is the set of all points equidistant to a point and a line. And we call that point the focus, and the line is called the directrix. Okay. So a circle is the set of all points equidistant. So it starts the same way here to a point. That's it. So if we pick one point and pick a particular distance and make all the points that are the same distance from that one point, we get a circle. So what do we call that one point? Or where would that one point be in reference to the circle? That would be the center of the circle, okay? And equidistant, that would be our radius, right? So circles are made up of two things, a center and a radius, okay? And so there's an equation of a circle. So let's say the center of our circle is HK. There's our point. And then we have a particular length, which we call R. And then we swing that length all the way around. Here's all the set of points. It's not going to be a perfect circle here, but it creates a circle, right? Yeah, it's a bad circle. All right. And if we pick any point on this circle, it's all the same distance from the center, right? And so let's call this a generic point xy. Anybody remember the distance formula between 2 points? Okay. If you forget, it's the distance formula is derived from a right triangle, Pythagorean theorem. So let's make a right triangle. It's easier this way. Okay, so here's a right triangle. If this point starts at h, we're talking x here, okay? Look at the x values. And then this is going to be perpendicular to this point. So this ends at x. So what's the distance between h and x? How do you find the distance between two numbers? Subtract. So it'd be x minus h. Okay, so x minus h would represent the distance of the base of that triangle. What would represent the distance of the height of that triangle? Y minus k. So use Pythagorean theorem, and what do we get? X minus h squared plus y minus k squared. Pythagorean theorem, a squared plus b squared equals c squared. And this is the equation of a circle. Okay? And notice, okay, so your equation has x and y. That's your variable. That stays x and y. But h and k relate to what? The center of the circle. Notice it's opposite, so you have a minus h here, so you have a positive h here, so it's just opposite value. Minus k here, you got a positive k here, opposite value again. And then this, whatever it's equal to, will be the radius squared. Do I have a question? Well, is there a difference between x minus h squared and h minus x squared? Is there? Is there a difference between 3 minus 2 squared and 2 minus 3 squared? What are they both? What is the first one equal? They both equal 1. Okay, give me another example. Give me anything you want. Bring it on. Give me whatever you want. You try it out, okay? So let's try this now, okay? We have a center at 2, 3, a radius of 5. Okay, here's our equation. So, or a general form of the equation. So what would I write? X minus 2 squared plus y minus 3 squared equals 5 squared. And there's your equation of the circle. That's finished. That's the finished form of a circle. How did I get 25? Because notice it's the radius squared is what it's equal to, and my radius is 5. And so I got 25 by squaring the 5. Okay? All right, let's look at another example. Number 2. Still want to write an equation of a circle, but this time I'm going to give you the endpoints of the diameter of the circle. So the diameter is a chord in the circle, so it's a segment that passes through the center, right? And what else do you know about a diameter? Double the radius, okay? What 2 things do we need to write an equation of a circle? We need the center and the radius. Did they give us either of those? Well, they gave us the endpoints of the diameter. So we need, our first thing is we need to find our center and our radius. Once we have those, then we can write our equation. So they do give us enough information, but we need to work with the information given to us. So we have this circle, 7, 1 and 7, negative 7. So let's make that 7, negative 7 down there, and 7, 1 up here. So can anybody tell me what the center of that's going to be? Okay. Now, in general, do you guys know how, the midpoint formula? We did this in Math 2. Let me bring it up again. So the midpoint of 2 points, so one point's x1, y1, and x2, y2 would be our other point. Anybody remember what we do? You find the middle of x1 and x2, so you average them. Find the middle, the average, and find the middle or the average of your y values, which makes sense if you're finding the midpoint, okay? So it's the middle of the x's and the middle of the y's. In this case, it's not too difficult because it's vertical, but if it was slanted, you'd want to know this, okay? So here, our midpoint's going to be 7 plus 7 over 2, and 1 plus negative 7 over 2, which is going to be 7 comma what? Negative 3. Okay, so we have our center. Okay. Our radius is the distance from the center to any point on the circle. This, again, is not too hard. So if we're at 7, negative 3, how far do we have to go to get to 7, 1? Going up 4. So our radius is going to be 4. And so once you have those 2 things, we can write the equation of that circle, which would be x, keep going, what is it? Minus 7 squared plus y plus 3 squared equals 16. Yes, Michael. I'll tell you in a little bit. Okay. Any questions? I want you guys to be okay with what we're doing so far. Okay. So now we're going to go the opposite direction. We're going to start with the equation and try to get the graph. Okay? But in order to do that, it has to be in the form we're used to seeing, and it's not always going to be in that form. So we need to get it into that form. Okay? And we're going to use the same technique we use with parabolas. We're going to complete the square. Because if you look at this, we have a perfect square here, x minus 7 times x minus 7, and we have another perfect square here. So we're going to use that technique twice, once for the x's, once for the y's, to get it into that form. So we want to find the center and radius of the circle. Here's the equation of the circle. First thing I'm going to do is group my x's together and group my y's together. So x squared plus 8x, and then y squared minus 10y equals 0. And I'm going to copy that down one more time, and because I'm going to be adding a little bit more to this line here. So I want to complete the square. The first one, the x's, I want to become what squared? X plus, this is when we take a look at the 8, we cut it in half, and we want it to be a plus 4. So if I want a plus 4, what am I going to have to add over here? Right, we cut it in half, and then we square it, and we get 16. Now, by putting that plus 16 there, not balanced, right? So what could I do? Subtract 16, or add 16 to the other side. And I'm going to add 16 to the other side because that's where I want my constant numbers to be. I'm just setting it up for the form. Okay. Plus, now we're going to do the same thing with the y's. What's the y's going to factor to? Y minus 5 squared. And again, I know that because I'm taking half of the negative 10 to get the negative 5. And so what do I need to add? Positive 25. And so I'm going to add that over here as well to balance out my equation. So this is going to equal 16 plus 25, which is 41. Okay. Now it's in the form I want. So what's the center of my circle? Negative 4. You do the opposite. Okay, I have a plus 4 here, so I'm putting a minus 4 here. And positive 5. And the radius, so 41 is my radius squared. Not my radius, it's my radius squared. So if I take the square root of 41, that's my radius. Okay. Yeah. So here's the equal sign, right? If you're going to work just on one side of the equation, then I'm going to add and subtract. Because that's what we did with parabolas. We left everything on one side of the equation. And that's fine. Say I did that. Say I put a plus 16 and a minus 16. And I wanted to move that minus 16 to the other side of the equation. Then I had to add it. No, as long as it balances. So there's two techniques. There's this. So if I have something very simple like 5 equals 5, we know that's true. If I want to add 3 to the left side, right? I have two options. I could either subtract 3, and it's true, or I could say 5 plus 3 is 5 plus 3, and that's also true. So both are okay. This is the method. The first one's the method we use with parabolas because we want to keep everything on one side of the equation. With circles, we actually balance it this way. Okay. So why don't you guys try that process on this next example? See if you can get it in the right form and choose the right center and radius. What are you guys getting for the center? -1, -2, good. And the radius? What is it? 2 square root 5, good. All right, and I'll show you that. Okay. So you first group your x's. So your x squared plus 2x go together. Your y squared plus 4y go together. Then you think about how to complete the square. I need to add a 1 to the x's so it factors to x plus 1 squared. I need to add a 4 to the y's to factor that to y plus 2 squared. Make sure you balance. So you get 20 on the, it's equal to 20. Also, don't forget to simplify the square root of 20 to 2 root 5. How are we doing with circles? This is as complicated as circles get. Okay. I got one more example though, but circles are easier than parabolas because there's only two pieces, center and radius. Okay. So last example is I want to show you what to do if it's an inequality. Okay. So it's still a circle, but when we graphed inequalities before, what were the two things we had to think about when you graph an inequality? So when you're graphing though, what are you putting on your graph that's different than if it's just equals? What's that? Is it dashed or solid? And where do you shade? And so that's what we think about here. Is it going to be dashed or solid? And we can answer that already. If you got the equal sign, it's going to be a solid circle. And then there's two places to shade, inside or outside the circle. And so we're going to have to decide which way it's going to be. Okay. So first, let's graph the circle, and then we'll decide where we're going to shade. So what's my center? 5, 0. And the radius? Okay. So I start with my x and y axes, find the center. There it is. And then from the center, I'm going to go up 5, down 5, left 5, right 5, and then mark out those points. And then try to draw a circle. I don't know, something like this. All right, there's my beautiful circle. Okay. Now shade in or shade out. Now, one way to do this, and probably the best way to do this for you guys, is to test a point out. Okay, you're going to shade where it's true. You don't want to shade where it's false. So pick a point you know for sure is inside or outside the circle. Doesn't matter to me. What's that? 5, 0. The center? Okay, great point. So if I plug in a 5, 0, plug in the center of your circle, what happens? I get 5 minus 5 squared plus 0 squared is greater than or equal to 25. And this is 0 plus 0 is greater than or equal to 25. Is that a true statement or false statement? Who said true? Is that you, Michael? Okay, that's false. So I picked a point inside the circle. Okay, I picked 5, 0, which came from inside. Oops, inside the circle, and it came out false. So where should I shade? So shading everything on the outside. Okay.